Okay, and chapter 7.5 is all about comparing fraction factors and products. And your learning goal for today is to be able to describe the size of a product compared to the size of a factor when you're multiplying fractions. So let's remind ourselves really quick, what's the difference between a factor and a product? What is a factor and what is a product? Go ahead and talk to your table group. Yeah, so a factor is what you multiply to get a product. So if I have 3, oh, hold on one second. That's way too fat. Okay, if I have 3 times 2 equals 6, if I have this multiplication equation, what number is the product, Joseph?
6.
6. The answer to a multiplication problem is the product. What number is a factor? Siddharth?
2 and 3 are the factors.
So 2 and 3 are both factors. Okay. So today we're going to be comparing the size of the product to the size of one of the factors. Okay. But first, let's talk about the problem of the day. What is multiplication? We've talked about how multiplication is repeated addition, right? But we can also think of multiplication as resizing one number by another number. For example, 2 times 3 is resizing the number 2 by what number? 3, right? We're making 2 3 times as big to get the product of 6. Okay. So the product is 2 times as big as 3, or 3 times as big as 2, right? So we're resizing one of the factors by the other factor. We can either think of it as making 2 3 times bigger, or we can think about making it 3 2 times bigger. Okay, so we're resizing one factor by the other factor. Now, today we're going to think about what happens to the size of our product when a number is multiplied by a fraction rather than a whole number. Okay, so if I have 2 times 1/2, I'm going to resize one factor. I'm going to make it half as big. So what is 2 times 1/2? 1, right? Because the product is half as big as 2. We're resizing the products, okay? Now, let's look at this problem. It says, during the week, the Delgado family ate 3/4 of a box of cereal. Okay, so go ahead and write 3/4 of a box of cereal in your notebook. And then draw this model that you see here. Why do you see a box that's divided into 4 equal parts? Why are we drawing a box of cereal that's divided into 4 equal parts? Marcus?
Because it said there's a box of cereal, and if the denominator is 4, that's how many pieces there are in total.
Yeah, we're dividing it into 4 groups because the denominator is 4. Now, let's shade in this model in your notebook. Please shade it in to show that 3/4 of the box of cereal was eaten. I'm going to shade in 1 part, 2 parts, and 3 parts. Now, how could we write an expression, meaning a math sentence, that shows that 3/4 of one box of cereal was eaten? How could we write a math equation? Go ahead and write it next to your model. So a math expression that shows 3/4 of 1 would be 3/4 times 1. Now, let's take a look. What is the answer? What is 3/4 times 1? 3/4, right? So is the product equal to, greater than, or less than 1?
Equal to.
Is the product equal to, greater than, or less than 1? How do you know it's less than 1? Tanvi?
But because I know that 1 is the same, you can convert 1 to 4/4,
Mm-hmm.
and 3/4 is less than 4/4.
Right. So 3/4 is less than 1. The product of this turned out to be less than 1. How come? Why was the product less than one of the factors, which was 1? Go ahead and talk to your family. Has 4 boxes of cereal, and they ate 3/4 of all of that cereal during the week. Okay, so first draw a model that shows 4 boxes of cereal, each divided into 4 equal parts. If the Ling family ate 3/4 of this box of cereal, how many sections should I shade in? How many sections should I shade in? 3, okay. But did they only eat 3/4 of one box of cereal? No, they also ate 3/4 of the second box of cereal, and the third box as well, and also the 4th box. Okay. What math expression does this show? 3/4 of how many boxes of cereal? 4. So how can I write 3/4 of 4 as a math expression? Ariel? 3/4 times 4. Okay, go ahead and count. How many fourths did we shade in here? 7, 8, 9, 10, 11, 12. How many fourths did we shade in? 12. But is it 12 fourths? How many total sections are there? 12 16. Actually, wait, hold on. No, how many fourths? There are fourth sections, so there's 12 fourths, right? So if I put these together, how many boxes of cereal did they eat altogether?
3.
So that's 3 boxes of cereal. Now let's take a look. Is the product of 3 greater than, equal to, or less than one of your factors, which is 4? Rashika?
It's less than.
3 is less than 4. Why did the product get less than again? Why was the product less than the factor? Soham?
Because we're multiplying 4 by a whole number. By a fraction, so it's getting smaller.
We're resizing it. We're making it only 3/4 as 3/4 times as big as itself, okay, which is less than itself. Okay, let's take a look at this one. Now, if they only had half a box of cereal at the beginning of the week, did they have this whole thing? No, they only had half, right? They only had that blue part. Now, did they eat all of the half? How much of that half of box of cereal did they eat, Misaki? They had 1/2, but then how much did they eat? They ate 3/4 of that. So they ate 1 section, 2 sections, and 3 sections. How much of the whole box of cereal did I color in both colors? 3/8 of it, yeah. Okay, now we've shaded 3/4 of 1/2. What's a math expression that could show 3/4 of half of a box of cereal? What's a math sentence that we could write that shows 3/4 of 1/2? Because we know that the word of, we can just replace that with what kind of symbol?
Times.
A multiplication symbol. So 3/4 of 1/2 is 3/4 times 1/2. And what did we say the product was? 3/8. Now, my question is the product equal to, greater than, or less than 1/2? You can see that our product is less than both of our factors. Now, why is that? Why is it less than our first factor of 1/2 and also less than our second factor of 3/4?